Hi, boys and girls. In this episode, we look at factors versus multiples. Our objective to differentiate between multiples and factors. Engage. Use the clues to work out the numbers from the 8 possibilities given. All right, so let's look at this now. It says I am an even number. Okay, so we can take out anything that is odd then. So it would be 3 would be gone, 15 would be gone, 25 would be gone, 17 would be gone because it says I am an even number. I am not prime. Okay, so we have no even prime numbers, okay, except 2, and 2 is not here. One of my factors is 3, all right. I'm not a multiple of 4, so not a multiple of 4, so that takes out 12 because 3 times 4 would give us 12. 4 times 5 would give us 20. So 20 is out as well. So this one is out. And now we're left with 10 and 6. One of my factors is 3. Let's look at the factors of 10. So if we had 10, 2, and 5. So these are factors here of 10. So 10 is out. All right, let's look at 6. Okay, if we have 6 here, factors would be 2 and 3. Okay, so the correct answer here would be 6. So it says here, Joe likes playing cards. He decides to play a game of factors and multiples. From his deck of cards, he selected the ones shown below with A symbolizing 1. His game follows these rules. Select at least 2 factors of a number. Select at least 2 multiples of the same number. You are to find as many factors and multiples as you can using the numbers 1 to 10 only. Write your selected card on either the basket marked factors or the basket marked multiples. All right, you can play that game on your own. Let's move. Based on your understanding of factors and multiples, complete the table below. Meaning, factors, these are numbers that can divide another without leaving a remainder. And multiples, those would be the results of multiplication. Okay, so what it is, number of factors, outcome, operations used. All right, let's see if we can do a little bit of this. Let's see. So here are examples. Multiples. So 6 is a multiple of 2 and 3. Okay. We have the outcome there. Operation used, this would be multiplication. All right, I guess we can stop with that. Explain factors. The term factor is used to mean the numbers which divide a given number perfectly, that is, without leaving a remainder. For example, 2 is one of the many factors of 8. Since on dividing 8 by 2, we get 4, and it does not leave any remainder. The other factors of 8 are 1, 4, and 8. Let's see if we can get another example with 9, factors of 9. So let's go, we'd have 9, and we have 1, 9, and 3. Okay, so 9, 1 can go into 9, 9 times, 9 can go into 9 once, and 3 can go into 9 3 whole times, no remainder. Multiple in mathematics, the product of 2 whole numbers is defined as a multiple of the numbers. For example, 2 by 4 is 8. That is, 8 is a multiple of 2 and 4. In addition to this, a multiple is a number that can be divided by a given number exactly, and it does not have any remainder. Multiples of 12 are 12, 24, 36. right? 12, 24, 36, 48, 60, 72, 84 are all multiples of 12. Facts about multiples. Each number is a multiple of itself. Every number is a multiple of 1. 0 is a multiple of every number. The first multiple of every number is a number itself. So, a multiple of a number cannot be less than the number. Multiples of any number are infinite. So let's talk about this. So if I'm going to talk about multiples of 2, then it would be 2, then 4, then 6, then 8. I could not say 1. I have to start with 2. Okay? The multiplication table. 2 times 1, 2, 2 2 is 4, 2 3 6, 2 4 is 8, 2 5 is 10, 2 6 is 12, and so on. Okay? If we were going to do multiples of 3, it would be 3, then 6, then 9, then 12, then 15, 18, and so on. Okay? Factors now versus multiples. Factors are described as a list of numbers each of which completely divides a number. That is, it is a perfect divisor of a number. On the other hand, multiples are a list of numbers which are actually the products of that particular number. 1. A factor is a number that can be multiplied with a particular number to obtain another number, while multiples are the product which is reached after multiplying a number by a whole number. 2. The number of factors of a particular number is limited, but the number of multiples of a given number is endless. 3. Factors are either less than or equal to a specific number, unlike multiples which are greater than or equal to a given number. 4. The operation used for obtaining factors of a particular number is division, as opposed to the operation used for getting multiples of a number, which is multiplication. Now that you understand factors and multiples, revisit what you wrote above and make the corrections. Extend. Let's continue to play this factor and multiple game. Get a friend to play with you. This is a game for 2 players. The first player chooses an even number that is less than 50 and crosses it out on the grid. The second player chooses a number and crosses it out. The number must be a factor or multiple of the first. The players continue to take turns to cross out numbers, at each stage choosing a number that is a factor or multiple of the number just crossed out by the other player. And here they have provided you with the grid, and you could start playing that game and see how it goes. Read and answer the following. Megan decided to make baskets for a fundraiser. Balloons are sold in bags of 20. Party horns are sold in bags of 10. And there are 8 candy bars in each package. How many of each should she buy so there are an equal number of balloons, horns, and candy bars in each basket? Alright, so for this, let's see if we can do this one quickly. We'll try to find the lowest common multiple of 20, 10, and 8. Let's say 20, 10, and 8. And 2 first. This goes into 20. 10 times goes into 10. 5 goes into 8. 4. Then 2 again. I'm going to use that. 2 into this. 5. Right back 5. 2. 2 again. 2 into 2. 1. Right back or 5. And then 5 into 5. 1. 1. 1. Multiply everything on the outside. 5 times 2, 10. 10 times 2, 20. 20 times 2, 40. Okay? So the lowest common multiple would be 40. Now, what does that mean? It means then that she should buy 2 bags of balloons If they are sold with 20 each, so she'll have 40 balloons. 4 bags of party horns, because they are sold in packets of 10, right? And she should buy 5 packages of candy bars because those are sold in packages of 8, and 5 eighths would give you 40. This way, each basket can have 40 balloons, 40 party horns, and 40 candy bars. All right. All right. Next one, a radio station is having a promotion in which every 12 caller receives a free concert ticket, and every 15 caller receives a free limo ride. Which caller will be the first to win both? Okay. So it would be here again, finding the LCM of 12 and 15. So 2 can go into the 6 right back, or 15. 2 into the 6 would go 3 times right back, or 15. Now we have 3, and 3 can go into the 3 ones, 3 into this 5. Then use 5, right 1, 1. 5 3 is 15. 15 times 2, 30, and 30 times 2, that would give us 60. So the 60th caller would be the first to win both the tickets and the limo ride. All right, so here we have, this says Cubs, but they should be cups. Cups are sold 5 to a package, and plates are sold 10 to a package. And if you want to have the same number of each item for a party, what is the least number of packages for each item that you would need to buy? So again, we're looking at the LCM there, the LCM of 5 and 10. So 5 and 10, and let's factor this out. 2 into the 5, no, 2 into the 10, 5, and then 5 here, 1 and 1, multiply these, and we have 10. Okay, so you should buy 10 packages of cups and 10 packages of plates so that we can have an equal amount there. All right, so Mello has 15 oranges, 9 peaches, and 18 pears. She wants to put all of the fruits into baskets, with each basket having the same number of pieces of fruit in it, without mixing the fruits. What is the greatest number of fruits Mello can put into each basket? All right, I'm gonna try this. I think that for this one, we could factorize each of these. So we have 15, we have 9, and we have 18. Okay, so 3 can go into this 5 times, 5 can go into this once, 3 can go into 9, 3, 3 into 3, 1, 2 into 18, 9, 3 into 9, 3, and then 3 into 3, 1. So the factors of the 15 would be 3 and 5. The factors of the 9 would be 3 and 3. The factors of the 18 would be 2, 3, and 3. Now, which one can I find in all? I could find 3. So it means you could put 3 pieces per basket. All right, let's see what that would look like. So let's see if we're right. So we're going to say 15. Let's say she has 15 for the oranges, 9 for the peaches, and 18 for the pear. 8 and 9 would be 17. Okay. 17 and 5 would be 22. 2 carry 2. 2 and 1, 3 and 1, 42. Okay. So 42 divided by 3. Let's see. Or 42 here. And we divide by 3. Let's do this over. Make this as a neater. Okay. So 42 divided by 3, 3 into itself 1 time, 3 into 4, 1, remainder 1, 3 into 12, 4 times. So we have 14. So it means that she could have 14 baskets with 3 items each. Okay. So she could have 14 baskets with 3 items each. Maybe 1 pear, 1 peach, 1 orange with those 3 items, and we could get the 14 there. That's one way of thinking about it. Double check and let me know if you come up with anything or any other way of viewing this particular setup. So in this episode, we were looking at factors versus multiples. By now, you should be able to differentiate between multiples and factors. This requires practice, so take the time, go over, and if you have questions, drop them in the chat. Take care, and we'll see you in our next episode.